Lesson 3.4 is about percent change, and percent change is how much a quantity has changed relative to its original amount. Or if you grew from 3'4" to 3'8", what percent of your height did you grow that year is what we're finding out. So we're still kind of using the same equation, part equals percent times whole, but we're changing what a couple of them are. So our part here, it's still the part, it's the change. So if you went from 5'4" to 5'6", the change would be 2 inches. That's the part, and our percent is still the same, and our whole becomes our original, or where it started. So I have 3 equations on here. The first one is percent increase. The second one is percent decrease. And the last one is percent error. Okay, so for percent increase, we have the change equals percent times the original. So an alligator was 32 inches long last year and is 38 inches long this year. What is the percent change of the alligator's length? Okay, so the alligator grew. That's why it's a percent increase. So we have our change. Well, 38 minus 32 is 6 equals your percent times your original. How big was the alligator to start? Well, he was 32 inches long. Okay, so we don't know our percent, and to solve for our percent, we have to get this times 32 over to this side of the equal sign, and we do that by doing inverse operations. So we divide by 32, and we have 6 divided by 32, or how many 32s go into 6, and we get an answer of 0.1875. And remember, we're finding percent of the increase, so that's a decimal, which means its percent is the decimal place times it by 100. Its percent is 18.75% increase. For the second one, this is our percent decrease. So how much did it go down? So last year, a website had 40,000 visitors, and this year it has 37,000 visitors. What is the percent change from visitors from last year to this year? So we have our change. So 40,000 minus 37,000 is a change of 3,000 equals our percent times where it started, its original, which was those 40,000 visitors. So in order to get that 40,000 over to the other side of the equal sign, we need to do inverse operations, and we're going to do divide by 40,000. Remember that this just becomes 1. That's why we do it. It goes away from this side because it becomes 1, and 1 doesn't change anything. And then it goes over here, 30,000 divided by 40,000. And we're going to get an answer of 0.075. We make it a percent by multiplying by 100. So we get an answer of 7.5% decrease. For the last one, and this one changes a little bit, it's called the percent error. Okay, so our part is still our change. So it went from 3,000 to 3,296. So we get the difference between those two is 296 equals our percent times, and our whole, or our original, is the actual number, the thing that actually happened. So when we talk about Sean estimating that the attendance would be 3,000, but the actual attendance was 3,296, that's what number is going to go here. So it's not the original when we're finding percent error, it's the actual. So it's not original, it's actual when we're finding the percent error. But then we would still solve it the same way. We're still trying to find our percent. So we're going to have 296 and we're going to divide it by 3296 because that is the inverse operation of multiplying by 3296. 296 over here, 3296. This becomes 1, which is why it goes away. And 296 divided by 3296 gives us our 0.089, make it a percent, and it is 8.9%. He was wrong by about 8.9% is what that answer means down there. So 3-4 is using the same equation to cover 3 different things. So how much did something increase? By what percent did something increase? By what percent did something decrease? And by what percent was somebody wrong? Okay, so we're still using part equals percent whole. For the percent increase and decrease, we use our change equals our percent times the original or the starting point. And then just for that last one, percent error, we would use, see if I can type it in here, change equals percent, percent times, this is going to be your actual. So we'll put that up here on the screen so that we can cement that into our brain. Okay? All right. Thanks, guys.